Okay, hi. A very good morning to everybody. So thank you for taking the time off this Saturday morning to join us for this dialogue session. And so my name is Dr. Tan Chin Hon. I would be the moderator of today's session. And so today over here, we're very happy that our head of department, Professor Ng Su Hui, is with us. And at the same time, we are also going to have our Deputy Head of Undergraduate Program, Professor Chu Wei Peng. Professor Chu, later on, he's going to give us an in-depth sharing about our undergraduate curriculum. But before that, we will like to first invite our Head of Department, Professor Ng Su Hui, to just give us her quick introduction. And so without further ado, let me just hand the time over to Professor Ng for her to share with us about ISE.
Great. So good morning, everyone. Thank you again for joining us today. I hope you're all having a nice Saturday morning. My name is Su Hui, and I'm currently the head of Department of Industrial Systems Engineering and Management. And today, as Dr. Tan has mentioned, I'll give a brief introduction of what ISE is about and the potential of our program and graduates. So I'm sure all of you, or some of you might be wondering what industrial and systems engineering is all about. Well, let me ask you, have you wondered how Toyota produces over 24,000 vehicles each day, or how online retailers like Amazon or Shopee guarantees your mail order items delivered within 3 days at a low delivery fee, or how ride-hailing companies price their rides over the day? Well, these are some types of problems or questions industrial engineers work on. So in a bigger picture, industrial engineers engineer processes and systems with the focus on increasing productivity, reducing waste, and improving quality. It's about solving problems, optimizing processes, and making good decisions. So take, for example, in manufacturing, like in the production of cars today, industrial engineers help to come up with optimal production schedules that maximizes output by minimizing waste while meeting delivery deadlines. And you might ask, how do we do this? So industrial engineers will study the production process and then use mathematics to describe the process. Then with this mathematical model, we can examine the efficiency of the production process under different schedules. And this will enable us to identify the optimal production schedule. Well, this is the general outline of how we solve problems, but there are multiple challenges ranging from modeling complications and optimization difficulties that make solving the problem very challenging. And that is why we will need, we need a large toolbox, which includes calculus, probability, statistics, optimization, simulation, programming, systems thinking, and many more to help us carry out these steps effectively. Other examples of what we do in various other fields include coming up with optimal delivery routing plans that minimizes the number of trucks required to get your mail order goods to you as fast as possible and as cheap as possible. Or in many large organizations, like in hospitals, we help to re-engineer process flows to reduce wait times and increase productivity. So in solving these problems, the general approach industrial engineers take is to first study and model the problem mathematically, search and evaluate different solutions in order to find the best or optimal solution. And as you can see, the work that we do permeates almost all sectors and industries, as the skills that we imbue are strong fundamentals that are applicable across many different fields. So let's come back to the ride-hailing companies, and let's look specifically at surge pricing. Have you wondered how ride-hailing companies implement surge pricing or different pricing throughout the day? Intuitively, we all know that prices should increase when demand increases. The question is, by how much? So that we can match the demand to the supply. So to solve this problem, industrial engineers use our toolbox of mathematical and statistical methods, along with our skills to model the problem, and then evaluate the different possible solutions very quickly to find the optimal pricing strategy. So let's take a look at another example of something that we are all familiar with today, the current COVID-19 pandemic. We are all well aware of how this has affected and changed the lives of everyone. And we know that for us to return to some form of normalcy, there needs to be global vaccination coverage, as nobody will win until everybody wins. And this will This will require fast and efficient distribution of vaccines to people all around the world. There are, however, many challenges in distributing the vaccines, especially to lesser developed countries. This includes the cold chain storage required for many of the vaccines. We know that this is already a challenge for the planning and transportation for developed countries like Singapore. And it's a bigger challenge for developing countries and remote areas where there's usually very limited capacity in cold chain equipment, transportation capacity, and storage. So while the scientists in the pharmaceutical companies work on the vaccines, the industrial engineering colleagues plan and design logistics and distribution approaches that help to address the cold chain requirements. For challenging areas, this includes optimizing the vial sizes, hub locations, shipment sizes, and frequency to limit the requirements on the cold chain capacity. So vaccine is only useful if it can reach the people who need it, and industrial engineers facilitate that. So what about our career prospects? So as I've highlighted, ISE is applied across many different fields, and hence our graduates find employment across a wide range of industries, covering all the different sectors of our Singapore economy. So taking a closer look at the employment and how well our employers view our graduates, we can take a look at the latest graduate employment survey. Let me put my latest graduate employment survey of NUS, NTU, SMU, and SUSS graduates that was conducted by MOE and MOM last year. We see that in a plot of the median salary against the full-time employment rate, the overall median salary of all graduates last year was 3,800, and the overall employment across all programs was 84%. And our ISE graduates did significantly better than the median of both the salary dimension and also the employment rate, where our median salary was 4,500 against 3,008 overall, and our employment rate was much higher at 91.8% versus 84% overall. And only 8 degree program graduates had a higher employment and salary than our ISE graduates. So we are in the top 9 across all universities. And importantly, when considering both dimensions, our BEng ISE graduates top all other engineering programs. So this clearly indicates how much industry values our graduates, as they can find employment very quickly and are paid much higher. Industrial engineers also play an important role in the growth and development of the new economy. Supply chain and logistics will benefit from the rapid growth of e-commerce and the sharing economy. And competition between businesses will accelerate due to technological advancements across multiple fronts. So companies will need to seek out productivity improvements to remain relevant in the highly competitive market. And industrial engineers will be right in the middle of all this to engineer the processes, systems to facilitate the growth of this new economy. So here are some of our recent graduates who have gone on to work in tech and new economy companies. So as you can see, some examples of them on the left-hand side, they've gone into many different roles of tech companies where they look at strategy and growth in the new economy, managing the risk within it, and process and productivity improvements within their value chains. Our graduates have also taken on, some examples of them are here, and their job descriptions or titles. They've gone on to take on IT roles within these tech companies, many doing data science and analytics, and also algorithmic development to solve many of the real world challenges or problems that I've just highlighted earlier. So using our systematic approach to modeling the problem and then developing algorithms to enable quick solving of these problems. Our alumni have also been employed in other key sectors of our Singapore economy, with many in positions that help companies in their transition into the new economy and tech space. You can check out many of our alumni's profile in the following link, and videos of some of their sharing on how their background in ISE have helped them in their career and in their jobs and career development. So to summarize, our graduates have a useful set of analytical computing and system skills that can be applied across multiple industries. And this allows our graduates to seek out the best paying jobs, be protected against industry-specific shocks and trends, and find employment in an industry that they're interested in. And this again explains the high employment rates and high starting salaries of our graduates. And our skill sets are very well positioned for the new economy. So let me end here and maybe hand off to Prof. Chu, who will tell us tell us more in detail about our curriculum.
Hi, good morning. First, let me check. Are you able to see the slides?
Yes, we can see it. Looks good.
Okay.
Thanks.
Okay, thank you. So thank you very much for introducing me. So I am BEng, so the Deputy Head for Undergraduate Studies. And so what I'm going to do today is to share with you on our curriculum and how this curriculum will be able to help you to see what Prof. Ng have actually shared with you on the kind of activities or the job that you can actually do. So, so before that, let me also share with you some history about our department. I think that's very important, at least to let you know about the past history, the tradition, and where we are from, so that you know that our department is not a new department. It's actually been there since in the 70s. So generally, as you can see, our department was established in 1972 under the sponsorship of Ford Foundation. And we actually have launched our MSc program during that time, which was the first engineering master's degree program in Singapore. So you can see that our department has been there since more than 50 years ago. And of course, while our department was actually founded so much earlier, but the BEng ISE program was only launched in 2001. And if you recall, the reason why is because during that period, right, this is where the Singapore economy transformed to a knowledge-based economy. And so this is where industrial and system engineering discipline becomes very relevant for this job. So our degree program is accredited by Engineering Accreditation Board, so which is a signatory of Washington Accord, and also our department offer comprehensive education programs, which includes the BEng ISE. We also offer a BTech IME for part-time students from Polytechnic, and BTech Supply Chain Management. As mentioned, we also have offered Master of Science in Industrial Systems Engineering, Master of Science in Supply Chain Management, as well as a new Master of Science in Maritime Technology and Management program, as well as MS and PhD. So you can see that essentially what I want to point out from these two slides is that first, our department has been established more than 50 years ago, and this BEng degree is accredited by the EAB board, which is under the signatory of Washington Accord. So what it means is that when a student graduates with this degree, all the members in the Washington Accord will recognize this degree. And third, we also want to share with you is that our department offers a comprehensive education program, and we have a lot of faculty staff who comes from reputable universities to be able to offer a quality program to you all. Okay, as what Prof. Ng have mentioned, generally this is what industrial systems engineering is all about. So I guess one of the questions that's always been asked is the discipline very relevant to the current and future employment, and what are the opportunities, especially in Singapore? And this is where actually Prof. Ng have actually shared with you on some of the kind of jobs that industrial engineering takes. And so this particular presentation that I'm going to show, right, is not only to share with you the curriculum, but we will also give you an idea of what we do, and hopefully help you to understand why our graduates are able to secure the type of jobs and how our curriculum prepares you for this job. So as you know, okay, Singapore economy is on the digital transformation path. In the last two years, right, with the onset of pandemic, we see that there is an acceleration of digitalization permeating in many companies' processes. So if you look carefully at what digital economy is, right, it involves three major technologies. One is automation, the second one is IoT, and the third one is decision technologies. So in automation, which is usually now we are in the era of Industry 4.0, essentially we can see that robots and automated systems are replacing humans to perform a set of tasks. Hence, because of that, it is necessary to give a set of instructions to this robot to perform. And when you have a complex system with many different types of robots and automated systems interacting with one another, right, to perform different tasks to achieve a certain goal, then the challenge is, how do you ensure that these robots or automated systems are able to perform at the highest productivity? That is trying to remove bottlenecks, having a small waiting time, or even trying to sequence the task handling such as efficient. So this is where the second and the third technology comes in. Okay, for example, the IoT involves big data, right? And it is used to collect relevant information or data to fit into the decision technologies. And the decision technologies will perform the analytics on the data to draw important insights, and such as patterns, trends, and this information is input into the data-driven optimization models for making a decision. So the decision technologies are the brain of the system, which are used to create a smart system on how to deploy these robots or automated system to perform the task. So essentially, if you look at this part, right, where just now Prof. has shared to you, right, ISE is actually a discipline to help to create these smart systems. So you can think of it that way. So to share with you further, right, we have some initiative from our department in playing a big role in the digital transformation. And let me share with you some of these initiatives. For example, we have a Center of Excellence in Modeling and Simulation for next generation pods. Sometimes we call it C4NGP. And what is this center about? So if you know, right, or some of you are aware that the container ports in Singapore, which is located at Keppel, Brani, and Tanjong Pagar, as well as Pasir Panjang, eventually all these port activities will move into the western part of Singapore, which is a big reclaimed land at Tuas. So by 2040, right, all these activities will move to this Tuas area, and this is actually the port of the future. So what do I mean? It means that the kind of equipment that's going to be used there will be fully container port operations, right? Generally, goods are put into containers and eventually are handled by the equipments in the port to either move these containers into the hinterland of Singapore, or just sit in the port there to be loaded to another vessel. The reason is because for Singapore, right, transshipment activities, which it means that the containers that goes into the port goes to another vessel, right, is very high. It takes about, it's about 92% of the handling is all transshipment. So a very heavy activities on transshipment. And the port, right, in order to move these containers around, right, it's handled by three equipments. Generally, it's the key cranes that interact between the vessels and the berth side, which actually handles the container to move from the vessels and load it to the berth, or taking the container from the berth and load it into the vessel, right? So essentially, that is what the key crane does. And then you have the horizontal transport, which is a vehicle that ferries the container between the berth to the yard storage area. And in the yard storage area, you have a yard crane that actually handles the container and put these containers into the storage area. So you have these three equipments that is used to handle the container. And for this kind of activities, right, you can see that there is a lot of challenges involved. One is that first, the vessel size that cost on the port is getting bigger. One vessel can carry about 22,000 20 feet equivalent containers. And so for a vessels to want to go to a port, right, they would want their activities to be done within a short period of time. So the port staying time is very important for a vessel. And so Singapore is known to be able to provide such services like that, right? To be able to clear the ship very fast. And that's the reason why Singapore becomes a hub for transshipment for many vessels. And what are the challenges here? Okay, the challenges here is that, or where do we play a part in this new port? First, we work very closely with the authority, which is the MPA, Maritime Port Authority of Singapore, and also with the port operator like PSA, to look into various designs of the port in the fingers. So generally, the layout is very important. It's because by 2040, right, the port should be able to handle about 65 million TEU. So one TEU is about 20 feet container. So the question is that now you have this piece of land given to you, and how do you know whether this particular land that's going to use is able to handle 65 million TEU, which is a very large volume. In fact, the 65 million TEU means that it is able to handle twice the volume as what currently PSA handles last year, right, in terms of volume. So how do we know that this particular layout that is given to the port operator is able to handle 65 million TEUs? And so this is where we build a digital twin, okay, to be able to evaluate, for different designs that you put, and how much key cranes that you use, and the vehicles that you use, and yacht cranes that you use, and also the layout orientation, and how the vehicle actually travels from one point to another point. Be able to evaluate quantitatively whether this particular port is able to handle the 65 million TEU. So this is something that you will have an opportunity to learn. So this digital twin is based on the simulation knowledge, where you will be taught and will be able to develop a simulation model to evaluate the port. Now, besides that, right, we also have interesting problems within the port. For example, within the port, right, there are many challenges that needs to be addressed. For example, if you talk about the deployment of vehicles, right? So there are many tasks to be performed. And so the question is that, how do you assign which vehicle, right, which currently will be fully automated, to assign to which task? So, for example, in a particular finger of a port, right? So let's say example here, right? Let me go back to the slide here. This is for one finger, right? So in one finger, you may have about 300 to 400 different automated guided vehicles to ferry the containers between the berth and the storage area. And so the question is that, for the challenge statement is like, given so many vehicles and so many tasks to be performed, how do you deploy these vehicles to handle the tasks such that it's efficient, such that the utilization of the vehicle is high, such that they take the shortest path and things like that, okay? So there is where you have to build additional technologies to be able to help come up with a smart decision to be able to ensure that the vehicle are utilized heavily, and there is no bottlenecks, and there's small delays. Then secondly is that you look into the storage yard, right? So you have vessels coming in to call the port, and containers needs to be discharged and put in the storage area. So another challenge statement is, given all the containers that's going to be discharged, right? So where is the best place to store these containers, to which location of the storage yard? The reason why is that I mentioned to you, right? 92% of the handling activities is transshipment. So many of these containers will have to be placed back or to be loaded to another vessels. So placing the containers to which location of the yard becomes very important because it will affect on the productivity. So this is another decision support or decision technologies that have to be built, to be able to address this problem. And then also in terms of navigation, in navigations where you talk about safety of vessels that is navigating through the channels to be berthed onto the port, right? So the question is that how do you ensure that when the ship navigates through the channel to go to the berth, that it will have a minimum risk of collision? And so this is where you use data, like real-time data to be able to show where all the neighboring ships are, so that when you navigate through, you are able to sail through safely. So this involves machine learning and AI algorithm to be able to come out with some decision technology to guide the ship to the berth. So essentially, what I'm trying to show to you is that, so we develop decision technologies to be able to help to make smart systems. So hopefully this particular project will enthuse you to at least let you know what ISE does. Then we also have another center called Center for Next Generation Logistics. Again, this is a project that just now Prof. have mentioned about FedEx just now in one of her slides. So essentially, this is actually a project done by a senior student in our department that actually create these decision technologies to help to assign, which packages to go to which trucks, so that the total trucks that is being used is minimized. So essentially what you know about FedEx is that they do express packages. These express packages will come in from a plane that will be unloaded to the distribution center in the airport. And so there are so many packages there and a lot of information there. And so this information will contain, like, for example, where to deliver this package to the customer's location. So the challenge is, how do you allocate which packages to go to which driver or which van? And you want to do it dynamically. And the reason why it's dynamic is because of the fact that, every day when packages is unloaded, they are different, right? So the location to where to deliver the customer will be very different, and so the profile will change. So how do you assign these packages to the truck drivers on a daily basis, okay? So that you are able to minimize the truck. And so this will involve things like data mining and data analytics, where you do the analysis, which you have to first identify what is the right data and features and use. Like, you need to know what is the origin destination, the travel time, geographical region. Then it also involve modeling, where you try to build a data model for clustering and routing. And then based on this model, you will do optimization to form where is the best routing to take to the best zone, okay, to cluster these packages. So when you do clustering, it means that you are trying to assign this cluster to a particular van. And by doing that, right, then this is where you come up with a decision to eventually decide which packages to be assigned to which trucks, such that the total trucks is minimized. And as you know, in Singapore, trucks is very expensive. So having fewer trucks to be able to do the job will definitely save costs on the company, as well as reduce the operating running costs, like the fuel costs and driver as well. Then another project is in warehouse design, where, of course, in the past, when you talk about warehouses, people always think that it's for low-skilled workers, forklift operator. But today it's not true, right? Because if you look at the modern warehouse today, they are using what I call automated system, where the goods are bring to the picker, rather than the picker goes to the storage area to pick. And also, nowadays the picker may not be human; it may be robots, that is carrying delivering the goods or moving the goods around the warehouse. And so today, the kind of job skill that a warehouse management will require is someone who is able to build additional technologies to be able to deploy the robots and where to store the goods to the storage location. And so you can see that because of that, then the kind of decision that has to be made when you talk about warehouse is, first, what will be the right warehouse design to have, what will be the right automated storage systems to use, and the right material handling systems to use, and how many of them you should use to ensure that you are able to meet the capacity, right? You will need to have the right capacity to meet the forecasted throughput that this warehouse can handle. And of course, at a more detailed level is where is the right place to store these goods? How do you route the robots to pick the items? So these are some of the decision technologies that needs to be done in order to ensure that the warehouse is able to perform productively. Okay, so hopefully with this kind of examples that I showed to you, right, this is where we build a curriculum, all right, to be able to equip you, all right, to solve these kind of problems. So essentially, if you look into our curriculum that we design, right, we have about 5 knowledge profiles that we want to impart onto you. So one is systems engineering, the other one is data analytics and machine learning, and the third one is optimization and simulation skills, together with peripheral support like management, finance, innovation. So we carefully select the kind of modules that complements very well with the knowledge profile that we want to build with the knowledge profile that we want to impart to the graduates, so that they are able to do a proper management in the systems and also able to perform benefit and cost analysis, as well as some innovation concepts, okay, for this program. And also, of course, to be able to implement, we want to also ensure that you have some deep level of data literacy. So for example, if you look into systems engineering, what is this knowledge that we're trying to bring to you all? So system engineering is actually using system thinking approach to integrate various engineering, business, and management discipline to create successful new systems. So essentially that is the kind of skill set they want to impart to you, because we have to look at a big system rather than try to look bottom up, which that often give suboptimal solution. We want to teach you how to view we want to teach you how to look at a system holistically, and see how these subcomponents in the system interact with each other, because they will affect the goal, okay, or the task that you're trying to perform. So you have to look at the big system, okay, to have a big picture. Then secondly is data analytics and machine learning. So what do they actually try to address? So if you know about data analytics and machine learning, it's more dealing with the science of analyzing data to gain insights, trends, and patterns by using data modeling to help in decision making. And finally, optimization and simulation. This is part of the very important analytics that we try to impart to the students, which looks into how to apply mathematics to business operations and finding the best possible alternative given the constraints faced for a large and complex problem. And also for computing and digital literacy, we want to also make sure that besides knowing the concepts, able to build a model, you must also know how to implement it. And that's the reason why digital literacy is very important. So what it means is that having a computing and digital literacy skill, you'll be able to use computer technology to complete a given goal-oriented task. So essentially, that's what these 5 sets of knowledge profile will be able to help you to eventually do analyzing, innovation, innovate the process, do optimization, and eventually decide, make decision on this. So if you look into all these 5 skills, so this is the modules that we have actually prepared for you, to be able to meet this knowledge profile. So this does not include the common curriculum modules, all right? This is the modules purely for our major, all right, that will be able to map towards each of this knowledge profile here. So just to give you an overall view, of course, many of you know that the BEng degree is a 4 years honors degree. And what's the degree requirement? First, the student have to get a minimum of 160 MC. So 160 MCs, a regular module is about 4 MC. So it means that on each semester, you will take about 20 MCs of coursework, which is equivalent to about 5 modules. And that will comfortably help you to graduate within 4 years. And then, of course, you have to pass all modules required by university, faculty, and department. And there are certain requirements that you must meet. All right. So it means that you cannot just take any modules that you want. There is a certain guide on the kind of modules that you must take, right, to be able to graduate with a degree in Bachelor of Engineering in Industrial and Systems Engineering. So what is a module credit? Is a measure of workload. So essentially, one MC is equal to 2.5 hours a week of work. So for example, as I mentioned, right, if you are taking 20 MCs on average for each semester, so you are expected to put in about 50 hours of work in clearing the 5 modules. And these hours includes contact hours, preparation hours, project hours, and those hours that is needed to meet the course requirement. So what is the general structure? So as you know that you have just come very timely into the new curriculum structure that the university is that came out with under the College and Design Engineering. So essentially, the purpose of this new curriculum structure is to better prepare you to tackle complex and interrelated issues. And because of that, we have actually, or the College of Design Engineering have actually come up with what we call a common curriculum to be able to meet this objective, as well as a more flexible structure that allows students to be able to build their own pathway. So for example, in a common curriculum, you have about 15 modules, and out of these 15 modules, 6 modules are from the targeting on the general education, which gives you broad knowledges, okay, which is required by undergraduate students so that you are able to understand the general knowledge of many different aspects of education, not just within your major, but try to diversify yourself to be more intellectual, right? So the general education module is for that purpose, which is very important. And then besides that, we have a common curriculum, which consists of 9 modules. And these 9 modules comprises of 7 modules that is interdisciplinary in nature. So it is to try to provide you with knowledge of other disciplines, as well as 1 integrated project, which is equivalent to modules. So this integrated project is very important, and this is called a capstone project, which you will be doing in your able to work with industry, opportunity to work with industry, and to use your IE skills to be able to solve their problems. Then in the major requirement, you have another 15 more modules, which if you want to get a Bachelor of Engineering, Industrial and System Engineering, then you have to fulfill these 15 modules. And finally, you have 10 modules, which is unrestricted elective modules, which you can take any modules, not only within the College of Design Engineering, but also outside the College of Design Engineering. You can take modules in the College of Humanity and Science, and also in other schools as well. Okay, so this is unrestricted elective modules, but of course, what I would like to advise you is for this unrestricted elective modules, try to plan such that you're able to have more focus in it. For example, taking a second major or minor. So these are important to be able to build up your portfolio, to bring yourself to be more marketable and have more concentration rather than being too diluted. Okay, so essentially that's what a second major or minor or specialization is supposed to do. So this is another picture to show you what the kind of courses that you'll be taking. So you can see that this part here at the bottom here is the common curriculum. And this part here, right, is actually the major. Okay, so in the major, you have to take certain courses that will be able to allow you to graduate the Bachelor of Engineering with ISE. And after that, you have also the unrestricted elective component as well. So for ISE, this is the courses that you take. So modern estimation here is actually referring to the 2 mathematics course that you take, engineering professionalism, and also a compulsory industrial attachment. And besides that, these are some of the fundamental course that is important, okay, for knowledge for industrial engineering to have, okay. And so they involve courses like engineering principle and practice 1 and 2, probability and statistics is important, data structure and algorithm, operations research 1, probability models of application with statistics for engineering application as well as simulation, and 2 electives. So let me share with you on the key highlights of the BEng ISE program. So we have two courses called Engineering Principle and Practice 1 and 2. And the whole purpose of this is to engage you, okay, and also expose year 1 students to industrial engineering problems. So if you look into the curriculum of the past, right, we used to have a very rigid curriculum where, in the first year, you do a very fundamental course where you talk about science and mathematics. And so usually in the first year of the students' education, they wouldn't know what industrial engineering is or what mechanical engineering is because they take a lot of science courses and also mathematics courses. But now what we feel that is important that as year 1 student may come in, right, you must, we want to expose you to early to what industrial engineering problem is so that you can be excited about it, you understand what IE is all about and able to be exposed to this kind of problem so that you are able to appreciate when you come into the program early. So essentially the purpose of this course is to raise student curiosity and passion to ISE. And how do we do that? We will try to expose you to early to the problems motivated by real problems, examples, and the kind of teaching styles that we put into the engineering principle and practice 1 is more of blended learning, more of interaction, like studio-based learning, as well as some games that can help you to make the whole learning experience better and more lively. So for example, in engineering practice, EPP 1, right, or sometimes called principle and practice, we use what I call activity-based learning, okay, to form you into groups where you tackle problem, have class discussion, and also an opportunity to introduce some of the ISE methodologies that's used to solve the IE problems. And I mean, this is some of the simple examples where you talk about, trying to match between a male and female, and how do you try to get a perfect match, right? Not a perfect match, the best match, okay, between matching male and female, or maybe dating or something like that. And so you get a collection of men responses. You also get the woman responses in terms of ranking who they would like to have, to date with. And so, and then we also expose you to some solver. For example, in this class, assuming that you don't have good programming language, so we just use a very simple solver called the MS Excel solver to be able to help you to solve this kind of problem. So essentially to give you some industrial engineering problem to let you get exposed to them and show you what kind of ways that we can actually solve this kind of problems, right? Then the second one is the system design project, or sometimes we call it an integrated project. So this project is very important. And the reason why is because this is the opportunity for students to actually apply their knowledge that they learn in their class to a real problem. So in this system design project that we have, it is actually over 2 semesters, and the students are attached to a company, and the company will give them a problem statement where the company will have to solve and deliver this work to, or deliver the results to the company. And so, so this is an important part of a learning process because you will have an opportunity to actually do teamwork, proper presentation, able to articulate your ideas and present to the management, some of the skills that you cannot learn in class, okay? Where you can only learn in practice, where you actually work on the actual problem of the company, okay? And of course, I don't want to go through this in detail. So essentially some of the projects like preventive aging stocking in Shopee. I'm sure you know who is Shopee, right? Shopee is an e-commerce company. And so Shopee has these problems of aging inventory. And so how do you actually try to reduce aging inventory? So aging inventory are those inventory that the quality have depleted or is getting obsolete, and it's taking too much space in the warehouse, because if you take up too much space in the warehouse, it's cost to them. So how do you try to reduce this aging of this stock? And so this will involve analyzing the data analytics, looking into identifying which product is having a lot of aging inventory, and then come up with a model, right, to be able to make decision on how to reduce it through demand forecasting or through pricing. A better pricing will be able to help to speed up the demand. So there are certain strategies that you can use. So this is one example on how we train students to do analytics of the data to be able to come up with decision making. The second one has to do with Infineon, which is a wafer fab company that actually produces wafer, and so they need to do testing of this wafer to ensure that it is of high quality, right? There is no defective. And so when you do testing, right, one of the key challenges that they are looking in is that when you do testing, you have to release them in batches. And so the question is that, well, what will be the right interval of time to release the batches or release the batches? If you release too early, then you have so many different types of batches all hanging into the shop floor, which will create a lot of confusion, take up a lot of manufacturing space, which is very inefficient. On the other hand, if the interval of time of release is too long, then some of the testing machine might be idling, and which is also a waste of money because the machine have to be kept at high utilization because of a capital investment. So what would be the right balance to release? And so this is where for this project, students use a simulation model to be able to come up with a prototype or a model that is able to mimic the actual behavior of the testing of these machines, and then from there evaluate the different types of interval of releasing the batching to help you to make a better decision to balance between early release and late release. And then the third project has to do with Singapore Police Force. Okay, so what happened is that that there might be certain events, big events that the government's organizing, and so which requires police to station at different critical points to ensure there is safety, security checks, screening, and things like that, right? So the challenge is that because of these critical points that they have to assign police to, right? And the workload can be different at different timings. So the request of number of police to be there can be different and it's dynamic. So the question is, where do I place what you call the forward logistics base, where I can house all the policemen here, so that when there is a need for a higher workload, they can actually draw from them. So they may need to identify a few feasible sites to put this forward logistics base where all these critical points can draw the police from. So the whole question is that, where do I place this FLB, right? Such that the response times to each of these critical points is fast. Okay, and secondly is that how many of these policemen should I place in each of the critical points, because of the fact that the demand at different time for the need of the number of policemen can be different, right? So this is a challenge that they face, and they want the student to be able to come up with a solution. And so this involves optimization to build a decision technology to be able to help them to decide on where to locate this FLB and how many policemen to be housed in each of them. Okay, so essentially this is some of the companies that we have partnered with where a project is given to students. So you can see that we have a lot of companies that we have worked with, which provides students opportunity to actually work in one of those problems given by the companies. Industrial attachment is another important area where students need to at least be able to experience what is a real working environment. So for this kind of course, they spend 20 weeks in a company, provide good training for the students, let them expose the real working environment. And it's also a good way to provide opportunity for future employment. So if you like the company, and if you work hard, the company sees that you are very promising, they might even offer you employment, right? So this is a win-win relationship for companies and for you as well. And of course, we have another courses which called the BEng dissertation. So essentially is to expose you to research train you to have independent learning, and also each student is assigned to an academic advisor. And again, for BEng dissertation, right, it may not necessarily just be pure research, right? It could also be real problems, okay? Where, for example, if a student is able to be assigned to a problem that is under the Center for Modeling and Simulation Next Generation pod, then all the problems that we have are real problems with industry partners. And so students will have a chance to do research in real problems and be able to deliver results for them. We also have, in the university, we have also special programs like double degree programs within NUS and also overseas with French universities. We have second major minor programs, NUS Overseas College Student Exchange Program, as well as one of our own summer program, which is the NUS Georgia Tech Special Program. So students have a lot of choices, right? So besides the major that they're doing, they can also participate in some of these programs as well. So you can see that the partners university that we have for student exchange is very large. Okay, so you can actually go from to US to Europe to Asia to experience the exchange programs. And for the special program, okay, this is something that we have a special relationship with Georgia Institute of Technology. You know that Georgia Institute of Technology is top have a top industrial system engineering program in US, okay, and have been consecutively been the top in US. So, so what happens that the Georgia Tech will bring the students to Singapore and as well to China, and NUS students have the opportunity to also join this program and build network with these students as well. So you can think of it as like a short-term student exchange program, because you can actually go to Beijing, okay, and also do courses there with them. So for minor, double degree, and double major program, there is a lot in the university, and so the kind of minor and second major that we would want to encourage you to do that complements very well with ISE is in this area of, maybe you can do a minor in artificial intelligence, or second major in computer science, you know, data engineering, economics, information security. So these are some of the suggested minor majors that we will encourage our students to do, okay, so that they're able to complement the major program that you're doing in ISE. So, so just to introduce you that in minor in data engineering, this is part of the joint initiative that we have with the electrical and computer engineering as well as computing to come up with this minor in data engineering. And so if you like to have more experience, okay, or more learning into machine learning and AI, you know, this is one of the course, one of the minor that you can consider. So just try to wrap up everything. So essentially, if you recall, this is the major program, and this is a common curriculum. And so you can take a second major, okay, to complement with your first major, which is the ISE, or you can choose to take a minor and area of specializations, and second minor and first major as well. Sorry, so let me also share with you, I think I missed out some slide, is that some good news is that we are actually proposing 2 areas of specialization, and currently we are waiting clearance from MOE, so most likely will be approved. And these are the supply chain analytics as well as analytics and decision intelligence. So what does it mean? It means that when these 2 AOS is approved, right, then you can actually deepen your industrial and system engineering knowledge by taking this area of specialization here. You can see that the type of jobs that our students or the graduates does is in this particular area here in business and finance. The portfolio is business analyst, business consultant, digital technology, government and services, manufacturing, supply chain, logistics, which Prof. have actually mentioned earlier. So you can see that given this kind of job titles that you can look at, you can hopefully can understand why our curriculum that we prepare for you is relevant to this particular job titles, right? It's because we are actually training you to to have this 5 knowledge profile, which will be able to help you to perform jobs in these relevant job titles. So YSE, let me summarize: attractive pay, resilient, because the training that we provide to you is relevant across many organizations, and also interest as well. And what I want to also mention is that when you join our program, there are 2 important aspects that you can offer students. One is exchange. Okay, you have an opportunity to be exposed to overseas studies. And of course, one thing that I also want to emphasize is that these to be exposed to industry problems. And this is where we make you to expose early. So before even you go out to work, you will be able to actually solve real industry problems and have a lot of industry experience. So with that, okay, I will end my presentation. Sorry, I took up more time. Thank you.
Okay, thank you, Professor Chu, for the sharing, for giving us an in-depth understanding of our undergraduate curriculum over there. And so now, very quickly, I just want to move towards our Q&A section. So we thank you for the questions that you have shared with us over there. So let me just quickly run through the questions and we can take a look at them. Okay, so we have one question over here, which is where do most graduates end up working in? And so I believe Professor Chu just now has shared with us already. And so if you're to look at it, essentially our graduates are spread across a wide range of industries. And based on our surveys, we see about 1/4 of them joining the finance industry, about 1/4 of them joining the tech industries these days. And also we have about about half of the, about 1/4 of them joining the services, for example, like healthcare and so on. And at the same time, we have another 1/4 in manufacturing. So they're kind of well spread out over there. And I think, as mentioned by Prof. Ng and also Prof. Chu, it is our training, we are essentially giving you a set of skills that are going to be very applicable across a wide range of industries over there. And so that's why our graduates find employment across a wide range of industries. What are the career prospects of working overseas? Before I go to that, probably let me just open to Prof. Ng and Prof. Chu. Is there anything to add in terms of where our graduates are finding employment in?
Sorry, go ahead. Go ahead, Prof. Chu.
No, I guess what Dr. Tan have mentioned is true. You know, in the sense that many of our graduates works in many organizations across different industry, and where they come from. Just now, I already shown to you, right? They have different job titles, which is needed in each of these organizations. So I hope that just now my transparency will have already answered most of that. Prof, you want to say something?
Right. I think as Prof. Chu has presented just now, you know, as you can see, the curriculum is extremely, you know, I would say comprehensive and covers a fundamental set of skills to solve, you know, many different types of problems across different industries. So, you know, a key highlight of our curriculum is flexibility and versatility. Because what we actually imbue in our students is the fundamental skills to model and solve problems, and it's not specific to any particular domain or industry. So I think that is a big advantage for our students, and that's why you see them across the different industries or sectors.
Yeah, thank you, Professor.
So let me add the point. What Prof. is trying to say is that, okay, so that doesn't mean that our curriculum is diluted because of that, right? Because the reason is that we are not teaching students how to build a product, but we are teaching students how to innovate and design processes. And so these are methodological, and that's the reason why it's independent of our domain specific, because it's methodology. And so there is a lot of fundamental in it, and it can be very rigorous as well. Okay.
Yeah, thanks, Prof. Chu, for the clarification, and so Prof. Ng for the input over there. So let me follow up with the other question, which was related, which is that what are the career prospects of working overseas? So I think basically it follows from the idea that our graduates have a very versatile set of skills that can be applied to a wide range of problems. So basically, the world is your ocean over there. Basically, you can value add to any organizations that you join. So definitely, if you want to work overseas, then there are going to be a lot of these opportunities. And in fact, if you think about working overseas, very often it is the matter of having that opportunity. So because the challenge, it's essentially you need a residency in that particular country over there. So a typical route might be that you work in a you work in a MMC in Singapore, and then you get posted over there. Or alternatively, we get students who subsequently, if you do a graduate program overseas, and after you graduate, because you're residency over there, you might find employment over there. Okay, but fundamentally, that is more of a, sort of like a legal issue, right? Where you stay and so on. But the training gives you the skills that allows you to actually pursue a career overseas. So I haven't done a survey in terms of how many of our graduates are currently working overseas, but I do know that there are quite a few of them. Some of them via the sort of like graduate program overseas and then working there, or alternatively, some of them because of the MMC over here, sending them over there. Alternatively, there are some because their family are based overseas, and so that's why they head over there. Prof. Chu, Prof. Ng, anything else to add to that?
Yeah, so my past experience when I talk to alumni is usually they share the experience that they usually enter in the multinational company, and somehow the company will post them overseas. And so this is some of the kind of normal route that for graduates to be able to expose to overseas working is through the posting of the multinational company, which many of them actually, when I talk to them, they have this opportunity. So it's not like a small number. Yeah.
Yeah.
I would just like to add on also, it's not only the multinational companies. A lot of our local companies also have foreign offices overseas and foreign, like our government-linked companies. So a lot of our colleagues, our graduates, have also gone through that same route instead of, but not in the multinational, but through our local companies also, that they have posted overseas, both regionally and internationally.
Okay, thanks for those. And then we have a couple other questions. So we have one which is this course similar to the SUTD ESD? And so I would say that both programs are going to share quite a bit of similarity over there. So, but I think the key difference over here is essentially that our department has been around for much longer, and NUS has been around much longer than SUTD as well. And why is that? Why is that a point to note? It is because over these years, we have managed to build up our brand name, and we have also managed to establish a lot of relationships with both overseas universities and also companies, both locally and overseas as well. So what happens over here is that if you recall what Prof. Chu was mentioning, besides the modules that you are taking, two other aspects over there is going to be the study abroad opportunities and also the internships as well. And so it is because of our connections with the partner universities that we are able to offer a wide range of overseas opportunities for the student. So the collaboration we have with Georgia Tech is one such example. And the other one, internships with companies and also our capstone projects. Those are also basically with companies, and those actually come from the relationships that we have built up with these companies over the years over there. So the numbers don't lie. So if you were to look at our graduate employment survey numbers, our graduates are doing very well. Okay, and so I'm just going to leave it as that. I think you can pull out the numbers yourself and take it there. But I think we are very happy that we are value adding to our students, that we give them a set of skills, the experience that subsequently they are able to move on to find good jobs. I guess Professor Chu, Prof. Ng, anything to add to that?
Maybe just another quick point to add to our program being in NUS. So, as you know, NUS is the only comprehensive university in Singapore. So there are many opportunities here to take many other different types of classes. And as Prof. Chu mentioned, there's a lot of opportunity to take second majors and minors to help complement, your ISE skills, to create an even more multidisciplinary set of skills for yourself. So, NUS is, more able to provide you with all the opportunities to meet your interests and to complement your skills. The other point that is also useful to note is, as Dr. Tan has highlighted, our program has been around and department has been around for for many years. So we do have a very good network of alumni who have been very successful in their careers. And as students, reach their fourth year and start looking for jobs, this alumni network is extremely important. And even after that, in their careers, being connected to a good network of alumni is important. So we do actually have that. So that's the other, advantage that we have.
Okay, thanks, Prof. Ng, for the addition over there. And so I am sensitive of time, but at the same time, I think we do have a couple of questions which I guess are fairly related, which is that is ISE going to be, it seems like we do AI machine learning. So is ISE similar to computer science? And at the same time, there's a question about, is ISE related to business over there? So let me just give a very quick response, and then later perhaps Prof. Chu or Prof. Ng, feel free to chip in as well. So indeed, we do teach machine learning in ISE simply because it's going to be a very useful tool in terms of helping companies identify problems, solve the problems that they have over there. So, but one thing to highlight over here is that to us, machine learning is just one of the tools in our toolkit. So we're also going to have simulation. Prof. Chu has also highlighted we have optimization and so on. So AI, machine learning, these are basically just one tools that we have over there. So obviously, if I have a lot of historical data, I can make use of data analytics to do predictions and so on. But what if I don't have historical data? What if I'm launching a new product over there? Okay, and so basically, we are still able to tackle those problems, but you are going to need a whole different set of skills. So I hope that explains sort of like how we are different from computer science over there. Okay, the other one about business, indeed, business is also there to kind of help organizations improve, right? So I think at the risk of oversimplifying things, the difference over here is that a problem is going to be having multiple facets, multi-dimensional over there. Okay, there are going to be many aspects that you need to solve the problem in. At the risk of us oversimplifying things, the focus of ISE, we tend to focus on the more quantitative aspects. So that's where our data comes in very important, mathematical modeling, optimization, and so on. And at the business school, there's a greater emphasis in terms of the quality, the qualitative aspects over there, in terms of, let's say, motivation, leadership, policies, and so on. So obviously, at our end, we will cover some qualitative aspects, but our focus is going to be on the quantitative side. Just like how at a business school, they are going to cover a bit of the quantitative aspects, but the focus, generally speaking, is going to be more on that qualitative side over there. Okay, so obviously we can go on a lot deeper if we were to look specifically at the curriculum, but that is just kind of a broad overview, a quick response to those questions over there. Probably it might be too simple, I do not know. Prof. Chu, anything to add to that, or Prof. Ng?
Yeah, I have a quick answer for this computer science. Computer science is not just AI. I mean, you look at the computer science curriculum, right? Initially, I mean, mainly is a database and also programming as well, right? This is part of the computer science, but of course, AI do come in, for them to be able to solve problems and things like that. So AI is just an overlapping kind of methodology that is used by ISE and computer science. Because for ISE, we don't actually emphasize on database. We don't really make students be expert on programming, but rather we are more focused on the prescriptive analytics, which talk about optimization models, and the kind of methodologies that's used to help to build these data-driven optimization models using AI and so other optimization techniques, which actually Ching Hon has actually mentioned. So you can see that we focus differently. So we don't go to the beginning end where we talk about database and also programming. This is not where our main core skill is, right? But we do provide digital literacy enough for you to be able to, perform a task-oriented goal, to be able to implement the decision technologies to be used. And so decision technologies is where our main aim is, you see. Yeah, I hope that will be able to explain where we are.
Yeah, thanks, Prof. Chu. And so with that, once again, we thank everybody for the questions. We hope we have addressed them. And so we do have a pretty small group over here. So let me just do this. So if you have any further questions, right, let me just give you my email over there. Okay, and so you can directly contact me, .sg. Okay, and so if you have any further questions, feel free to just directly just email me, and then I will be happy to respond to that. At the same time, I'm just sharing over here, which is our department's e-open house website over there, where we have a lot of information regarding what is ISE, our career prospects, and you can go over there to also check out our curriculum as well. And if you go down to the footer over there, you would be able to see sort of like our social media, our LinkedIn page, our Facebook page. If you prefer to connect with our students, feel free to just check out their Instagram page as well. Okay, and so you can get the opinions about our students, why they decided to join ISE, did they have any regrets, and so on. Okay, so I think like what Prof. Ng said, we are a very close-knitted community over there, and so that is what we like. Okay, and so with that, I think we've come to the end of this session. Once again, we'd like to thank everybody for taking this Saturday to join us. We'd like to thank Professor Ng, Professor Chu for taking the time to share with us about our program as well. So with that, I'd like to wish everybody a good weekend, and I hope to see you at NUS soon. Okay, take care, and then bye-bye.